begin. We're going to talk about early quantum use cases, and this is the first of a number of videos. It's brought to you by Chicago Quantum. This presentation was published October 18 of this year. And keynotes to think about. The first is all of these use cases are experimental. None of them are in real production. All the data behind these are publicly available. And some of these use quantum-inspired technologies, including quantum simulation. We organize our use cases into three categories: quantum computing, such as optimization; quantum computing that is not optimization; and lastly, quantum technologies that are not based on computing directly. So here's a list of optimization cases. And we can optimize a lot of things in business. We can optimize travel routes, vehicle dispatch, order picking, digital advertisements, so that a computer can decide, which ad you post. Scheduling robots to do different things. Scheduling a complex repair shop. Ordering items for sale on a website so that you can maximize selling. And in terms of optimizing movement, waste and recycling trucks is a public case. And then for people, picking a new car and picking the configuration and the options that go together, it's called a recommender system. We've also seen cases that are not optimization. The first is verification and validation. A quantum computer can go through software and hardware, software code and hardware specs, and how they interact, and find possible areas of breakage. They can be used for molecule and material discovery, such as what is the structure, function, and how do I compare two different materials. And some of the use cases talked about are for things like making batteries, pharmaceuticals, or commercial chemical compounds. Very precise and accurate calculations and predictions of molecular properties. They're being used right now, or attempted to being used, to price equities, stocks, options, derivatives. They're also being used to improve MRIs, so scanners. And how it works is they can either make the scanner faster or they can make it more sensitive. A more sensitive scanner can detect anomalies in your body earlier, thereby helping to accelerate treatment and hopefully make cures. They can be used to quantify client risk in new ways. And lastly, from a telecommunications perspective, radio access network signal processing. So connecting mobile user devices to core networks, especially in 5G, can be improved with quantum computers. So for quantum technologies which are not quantum computers, you can secure terrestrial communications from space. So if I need to speak to somebody around the country, down the street, I can pop up that communication through a satellite. Or I can also do the communication using quantum key distribution so that I'm adding a layer of protection on that encrypted communication. The second is I can enhance radar detection. So not only can I see things underground, but I can actually have my radar be harder to detect by an attacker and better detection of incoming threats, like an airplane. It's also used for submarine detection. We can do navigation without GPS. Every once in a while, GPS goes down, or it can be denied in an area. So if I can navigate, let's say on the high seas, without a GPS in a completely passive mode, that's very valuable. I can have ultra-secure communication using photonics codes. So think of it as I create a key. It's based on photons, or little bits of light. And if someone else looks at that light, the codes go away and dissolve. It knows if you're looking at it. And so I can have very secure communication cross-country, Again, down the street, you could think of a client that has a data center and they back up their data. I can ultra secure that link. Another way to securely communicate is via the Earth's magnetic field using quantum technology. I can detect movement and activity over long distances using quantum technologies. Long distances, but also very short distances, like within the human body. Quantum technologies can be used to map brain activity. It can be used for gaming industries to ensure randomness, because quantum random number generation is based on a physical randomness, not pseudocode. So, picking lottery winners is an obvious use case for quantum random number generation. And it's not just picking one lottery number, right? I can use balls like PricewaterhouseCoopers used to use for the weekly lottery. But what if I have to pick 3 million lottery winners every time? That's the case that we talk about. Atomic clocks. Think of it as 1 qubit. It's very accurate. And then finally, I can make better TVs, better LED displays, and lighting solutions, especially colorful lighting solutions using quantum dots. I want to thank you for listening to the early quantum use cases. Stay tuned for part 2.